Welcome everyone. In this video I'm going to show you how to build a small laboratory power supply. So you can see the parts that I'm going to use for this power supply. In fact, this power supply will be a 2-channel or 2-output power supply, but I'm just showing you one because basically you just have to duplicate and then you can make it into 2 channels. So I have some wires here. You should use thicker wires because this is just 0.5 square millimeter, so it's not sufficient for high currents, but for demonstration purposes it's just fine. I will not put any large load on the output. And then this is the wire for the power, and then we have this power supply. As you can see, 12 volts, 30 amperes. So in principle it's a strong power supply for this purpose, because the next thing that I'm gonna use is a 300 watts DC-DC buck converter. So you have the input, so the power from this power supply will come in on these connections, and then this is the output. You can change the output current with the CC potentiometer. It's 100 kilo ohms potentiometer, and then with the CV you can control the voltage. So I have these 2 potentiometers here, so I will use them to control the output current and output voltage. So I will remove desolder these 2 trimmer potentiometers from the board and just use some wires. So then I have this power meter here. So these thicker wires for the power, and these thinner wires for the connection for the internal power supply of this thing. So basically this can show you the voltage, the current, the power consumption, and some other details. So it's very useful for a power supply. So basically this is all, and then just some other things to have better connections. And then for the potentiometer I have these knobs with different colors, and then this will be the output for the connection. So it's a banana plug, but you can also use this hole here to connect small wires. So basically this is just 1/2 of the power supply. So in the final piece I will use just one single power supply, but I will power 2 pieces of this. So there will be 2 outputs, 2 of these screens, and 4 potentiometer. So in the end you can build like a 4-channel power supply, and each of these things can withstand like 15 to 20 amperes. 15 ampere is suggested, and as the heat sinks are very small you should use a fan to remove the excess heat. And I think that's all. So first of all I'm going to remove these, and I have discovered that there is a small capacitor or resistor here for the voltage potentiometer. So I will keep it and solder it back once I have these guys connected. So I will just use some small wires and reconnect everything here, and that's all. And then I will wire up this power supply with the screen and with this DC-DC converter, and just put a small load on it and test it. And basically that's all, but I will show you all the smaller steps. So this is the removed potentiometer, or these are the potentiometers. We can see the wiring on the body. And now I will try to get the wires in and connect it with the other potentiometers, these guys here. So I have the wires, the potentiometers, some soldering stuff, and some heat shrink tubes. So first I fix the wires to the potmeters, and then I will fix them on the board. So these are done, and now I'm going to solder them on the board. Okay, so now I have the potentiometers replaced, hopefully in the good polarity. I checked it twice. Actually, I had to correct it. And solders looks fine. So now the next step is to, basically check it with a laboratory power supply. So I will give a small input voltage, and then I just simply check the output just to see if I messed up something before I put on more power. So both potentiometers are on the lowest position, and I will apply 8 volts on the input, and then I will just simply measure the output. .3 volts. So then I increase the voltage a little bit. Oh, 7.7 volts. So this seems to be a little bit sensitive. But it works, and it looks stable. Yeah, I feel like that I cannot use like half of the range of the potmeter. So now I made sure that it works. So I will assemble it with the power meter. So for the power meter, I would like to use these ferrules to make some nice connections to the wires, for the wires. In fact, these three guys are soldered, but these two big wires which should transfer the load, they are not. So I will fix them. So everything is nice and fixed. So I have to come back here and connect it. So now I have to decide how to connect this power meter to this buck converter. So what I want to do, I want to measure the consumption of this side. And there are several wires here. So some wires are for the internal power supply of this power meter to operate the screen and the other stuff, the electronics. And then we have these two thicker wires which transfer the load. So there is a small manual for this power supply. I will show you a link, of course, for this kind of power supply and also for this kind of power meter. So there are like three different ways to power this and measure the power consumption. And I want to measure the power consumption of the load and not this DC-DC converter. So therefore I have to choose which design I want to use. This shows you three designs. So you can have an isolated power supply, and you can have a DC-DC converter. So you use a separate converter to provide power for this, and then you measure a different thing on these two lines, on the thick wires. And then you can use the system itself to measure the power consumption. So I have to decide between these three methods. For me, I want to power this power meter from the power supply. So using this guy. So I would like to use one of the outputs here. And then I would like to measure the power consumption on this side. So therefore I should get the power for the power meter from this side of the converter, so before the converter. And then so these thin wires go on this side, just to make it more clear. And then these wires should belong to this side. So the power meter will measure the consumption on this side of the DC-DC converter. So we use this. So I have the power supply from this guy here, and then I use the positive and negative connections, and then I put this on the positive side of the buck converter. I put this on the negative side of the buck converter, and then this will be another connection. So this is the negative side of the load. So this will be here and between the positive side. So I will try this with a very low power supply and a small load. So I will see if it works or not. And possibly it should work, and hopefully I will not burn down anything. So I will power this with 12 volts. and I will power this with a separate power supply to see how it works. So now I wired up everything according to this drawing using an isolated power supply. So I use the plus and minus from an isolated power supply. I will connect it to a regulated power supply, and then I have the positive connection connected to the yellow or orange wire of this power meter, and then also the positive side of our load, which is a very small fan, is connected to the positive side of the output, and then the negative side is simply connected to the negative output of the DC-DC converter. So this goes in to the power meter and then goes out as the red wire, as you can see, and that will be used as the negative side. So then we will power the DC converter with another regulated power supply, and we will see what happens. So first of all, I will connect the power supply for the power meter to see if it turns on, and it works. So you can see all the details here. Now there is no power running through the output, so I will turn on the other power supply, which is connected to this side. So I'm not touching any wires. So it seems okay, but there is only a very low voltage, 1.3 volts, because I haven't turned on the potentiometer. So now what I will do, I will turn this pot meter. So I started to increase it. So now the load started to work, and the fan is running, and 3.8 volt is applied on this fan. So I will turn it up. You can even hear it now. So 8.7 volts, but the current seems to be 0. And now whatever I do, it's not changing. So maybe the consumption of this load is so small. In fact, it's very small, because if I see the consumption of my regulated power supply, it's 0.087, so 87 milliamperes, which is very low. So I can increase the voltage. Now it's, I think, running on the maximum, because now I'm just powering this side of the converter by 12 volts. So I cannot put 12 volts on this side, of course. We have losses and everything. So now this setup seems reliable. I increase the input voltage. And the output voltage changed as well. So this seems reasonable. I turn off the power supply now. So the power supply is off. The voltage is dropping slowly on this side, because we have capacitors and they have to discharge, of course. So we have everything. I remove the power from the power meter. And now I should see if I can do the same by connecting these two wires to the power supply. So now we have everything wired up. So these are the live wire, neutral and ground. This should not be touched. And then one part of the output of this 12-volt power supply goes to this part, to the power meter. And then another wire goes to the DC-DC converter. And then we have the same wiring. And here is our small load. So now I will get some connections and see if I destroy anything. So I connected everything according to this isolated power supply connection. So we will see if I destroy anything. Okay, no smoke came out so far. So the power meter is working, and no smoke is coming out from anywhere. The buck converter looks alright. So I think this works. So now I put a bit more serious load on the power supply, or on this kind of system. So we have our main power supply, which is a 12 volt. So we have our main power supply, which is a 12 volt 30 amperes power supply. It powers the power meter here, and it powers a DC-DC buck converter, which is connected to this thermoelectric device, 12 volts, 6 amperes, so 72 watts in theory. So I use these banana plugs to connect everything. And in the final version, I will have one of this, but I will connect 2 power meters and 2 DC-DC converters. So there will be 2 independent regulated power supply from this system. So at the end, this will have more outputs, but this is like the prototype. So let's power up everything and see how it behaves. So now I just put all the potentiometers to 0, and now I connect the light wires. So it seems to work. This side is cold. I can already feel it, but no power is running through it really. It's 0.8 amperes and 1.3 watts. So that is literally nothing. So let's increase the voltage. So it's more cold, and also let's increase the amperes. So now 2 amperes, 4 volts, and it still works. So I can see the output is 4 watts, 2.5 amperes, and 9 watts. I can also see the consumption, like 0.2 ampere hours, and the running time. I just have to make sure that the hot side of this doesn't get too warm. But I show you something. So this is like 5 degrees now. It's getting cold. And then the heatsink is 25 degrees. But this 4 degrees. So I can even I can further increase the voltage just for fun. And now like 25 watts is running through this thing. So now this is below 0 degrees Celsius, so it's quite warm, quite cold, but this side is still not too warm. And the converter is not getting warm that much, which means that the efficiency in this range is quite good. Now if you can see, it's roughly 6 volts and 4 amperes, so this is what we get. And I can further increase. Now we have 35 watts, minus 2 degrees on the surface of the thermoelectric element. It's very cold. So it works. Let's turn it off. So what I wanted to demonstrate for you here is that if you buy this kind of cheap power supply, you buy a power meter and you buy this kind of DC-DC converter, you can build your own 2-channel laboratory power supply. So I have one more of this and one more of this. So at the end I will have this main power supply, which converts the main power to 12 volt output. So I will use that 12 volts output to power 2 of these buck converters, and then power 2 of these power meters. So I will use the power meters to monitor the output voltage and the output current, which I will be able to control with these potentiometers, and that's all. So I just have to wire up everything and then put it in a plastic box, make sure that everything is safe. So this is all in principle. So you can use very cheap components to have your own regulated power supply. So you can change the current, you can change the voltage, and it's a very simple thing to do. So I hope it helped you, and if you need any help with this power supply, just let me know.